Hi again, this is video number 149. We try to explain some few common sequences. At first, the triangular number sequence. Term 1 is 1 dot. Term 2 contain 2 rows. The first row is 1 dot and the second row 2 dot. That is 1 plus 2. The third term is 1, 2, 3. 1 plus 2 plus 3. That's fixed. 1, 2, 3, 4 plus summation of 1, 2, 3, 4. That is 10. 1, 3, 6, 10. By adding 2 to the first term, we can find the second term. By adding 3 to second term, we find third term. Also plus 4, plus 5, plus 6. That is an is an minus 1 plus n. That is an minus 1 is equals to n. We can say the triangular number sequence is recursive sequence. Next one, a square number sequence. 1, term 1, term 2, term 3, term 4, one square, 2 square, 3 square, 4 square, bella, that is an is n square. Okay, an minus 1 is n square minus n minus 1 square. That is n square minus n square minus 2n plus 1. We have 2n minus 1. That is an minus 1 is 2n plus 1 minus 1. Sorry. That is an is equals to an minus 1 plus 2n minus 1. Cube number. A1 is 1 cube. A2 is 2 cube. A3 is 3 cube. That is an 1, 8, 27, 64 and blah blah blah. We can find the relationship depending between an and an minus 1 by this n cube minus n minus 1 cube. We have by decomposition n minus 1 n square plus n dot n minus 1 n minus 1 square. This is equals to 1, and we have an minus 1 is n square plus n square minus n plus n square minus 2n plus 1, that is 1 2 3 3n square minus n plus 1. Let me check. n square plus n square plus n square is 3n square, sorry, minus n minus 2n minus 3n, sorry, plus 1. The next one, sorry, Fibonacci sequence. In the type of Fibonacci's sequences, we have we define a few terms and determine and definition the other terms by this defined term. A1 and A2 equals to 1. The second one, the last one, is 1 plus 1 is 2. The next one, the next term is 2 plus 1. That is A2 is A1, A3, sorry, A3, A1 plus A2. A4 is A2 plus A3. A100 is A99 plus A98, and so AN for n greater or equals to 3, AN is AN minus 1 plus AN minus 2. Start by A1 and A2 equals to 1. That is the Fibonacci sequence 1 1 2 2 plus 1 3 3 plus 2 5 5 plus 3 8 8 plus 5 13 13 plus 8 21 and 34 55 and blah blah blah. The next one, arithmetic sequence. In arithmetic sequence we can give A1 and a constant element that is common difference. Example, A1 is 5, common difference is 3. Start by 5, the next one 5 plus 3, that is 5, that is 8, 8 plus 3, 11, 11 plus 3, 14. That is AN is equals AN minus 1 plus D, or AN minus 1 equals to D, common difference. Example, (17) common difference is 5, 22, 27, 32, 37, and the others. In arithmetic sequence, AN minus AN minus 1 is equals to D. Also, AN is A1 plus N minus 1 D. This is recursive formula, and that is explicit formula. Geometric sequences. In geometric sequence we have the A1 and ratio R or R. Each element is R multiplied to the previous terms. Example, A1 5 and R is 2, so we have 5. The next one, 5 multiplied to 10, 10 multiplied to 20, 40, 80, 160, 320. Okay, in geometric sequence we have an over an minus 1 is equal to R ratio, or an is R multiplied to an minus 1, that is an is a1 multiplied to R power n minus 1. That is recursive formula, and this one is explicit formula. Also we can see that am over an is a1 r m minus 1, a1 over a1 r power n minus 1, that is r over r power n minus m. Quadratic sequences. If a, b and c are real numbers, then an square plus bn plus c is quadratic sequences. In quadratic sequences, if an, a1, a2, a3, a4, and by 2 steps we can find a constant sequence. a2 minus 1, a1, a3 minus a2, a4 minus a3, the next one a3 minus a2 minus a2 minus a1, that is, this sequences is constant sequence. For example, an is n square plus n plus 1, a1 is 3, a2 is 4, 4 plus 2 plus 1, 7, a3 9 plus 3 plus 1, 13, a4 16 plus 4 plus 1, 21. So 7 minus 3, 4, 13 minus 7, 6, 21 minus 13, 8. So 6 minus 4, 2, 8 minus 6, 2, 10 minus 8, 2. So for example, identify the following sequences: 2, 3, 5, 8, 13, 21. Okay, 2 plus 1, 3 plus 2 plus 3 plus 5 plus 8. Okay, 3, 5, 8. 3, 5, 8. That is 21 is equals to 13 plus 8. 13 is equals to 8 plus 5. 5 is equals to 3 plus 2. That is Fibonacci sequence. Sorry, this one. 2 plus 4 plus 4 plus 4, that is arithmetic sequences. 1, 4, 1 square, 2 square, 3 square, 4 square, 5 square, that is quadratic equation. Sorry. Quadratic sequence, quadratic sequence. Sorry, 8, 27, 40, 64, 125. Sorry. So 2 cube, 3 cube, 4 cube, 5 cubes, that is cube sequence. An is equals to n cube. 5 plus 7 plus 13 plus 19 plus 6 plus 6. Okay, that is continue the following sequence by finding the next two terms. Okay, plus 7, 13, 19, 25 and 31. 25 adding to 44, 69. Adding 31, that is 100. 1, 6, 36, 216. Okay, that is 1 multiply to 6, 1 multiply to 6, multiply to 6 again, and fix cube. That is, the next one is fix power 4 and 6 power 5. The next one plus 5 plus 5 plus 5, that is fixed it 33 plus 5, 41, 46, and the other 28 plus 8 plus 9 plus 10 plus 1 plus 1, that is quadratic. I want to find the next terms. Plus 11 is 66, 11 plus 12 is 78. If you want to find explicit formula for this sequence, A1 is 28, A2 is 36, and A3 is 45. AN is AN square plus BN plus C. Sorry, I want to check. This one. Okay. A1 is A plus B plus C. Substitution 1 instead of N. A plus B plus C equals to 28. A2 is 4A plus 2B plus C. 4A plus 2B plus C equals 36. A3 is 9A plus 3B plus C, and so 9A plus 3B plus C equals 45. Okay. By subtraction, line 1, line 2, line 3. Okay. Line 2 minus, line 2 minus line 1. We have 3A plus 2B equals to 8. Line 3, subtract line 2. 9A minus 4A. 5A minus, that is B. 2B minus B. 3B minus B. Plus B equals 9. Line 5, line 6. So line 6 minus line 5. 5A minus 3A, 2A. 9 minus 1, A. Minus A, 1. A equals 1 over 2. Substitute A to this 3, 1 over 2 plus B equals 8. So B is 8 minus 3 over 2, 16 over 16, 13 over 2. By substitute to this one, A plus B plus C, or A plus B plus C equals 28. A and B, 1 over 2 plus 13 over 2 plus C equals 28. So 14 over 2 7, C is 21. So AN is equals to N square plus 13 over 2N plus 21. Thank you for your patience.